Thank you, Nana, for that amazing overview of the Hedera journey to EVM equivalence. So continuing on in this next talk, we're going to hear from the next speaker to tell us about actionable insights to build reliable and high-performing decentralized applications on the Hedera network. And so we're going to hear about how to work with the Hedera portal API, how to work with local JSON-RPC relays, and how to optimize your gas usage on the network. So please join me welcoming to the stage software team lead at ioBuilders, Alberto Molina.
Okay, so hello everyone. My name is Alberto. I'm a blockchain developer. I work for ioBuilders, which is a Spanish consultant company that specializes in blockchain. And we have done many projects with Hedera. And today I would like to share with you 3 testing tips that can be very useful if you're building on Hedera and testing your applications. So this is what I will be talking about today. So first, a little bit of context about a couple of open source projects that we have implemented that you have already heard many times today during many presentations. And then I will talk about the 3 tips. The first one will focus on the testnet account resilience. The second one is about what you should keep in mind if you're using local JSON-RPC nodes for testing. And the last one is about managing parallel testing properly. So without any further ado, let's move on to the context. So the first application that we implement is the Stablecoin Studio. Again, it has been mentioned many times today. It's an open source project that is basically, so from an architecture point of view, it's basically a dApp. So a bunch of smart contracts deploy on Hedera and a front end that communicates with them through an SDK. There is no backend. And the Stablecoin Studio is used to deploy and manage stablecoins. It integrates proof of reserve functionality through Chainlink's aggregator v3 interface. And it supports MetaMask, every single Hedera native wallet through Hedera Wallet Connect, and it also supports Hedera multi-sig accounts. And then it also uses every single Hedera service, HTS, HSCS, the mirror node, the JSON-RPC node, and so on. And then the ATS, the Asset Tokenization Studio, it is very similar to the Stablecoin Studio from an architecture point of view. It's also a dApp with a bunch of smart contracts. And it is used to deploy and manage assets. So far, we only have equities and bonds. And it includes corporate actions on chains, like dividends, coupons, depending on the asset. It supports the same wallets as the Stablecoin Studio, so MetaMask and Hedera Wallet Connect. And it also relies on the same services as the Stablecoin Studio. So the Hedera APIs, the JSON-RPC node, mirror node, and so on. So the first tip about testnet account resilience. So if you are testing your applications on the testnet network, which you will have to do at some point during the development lifecycle, you will need to have some testnet accounts pre-generated in order to send transactions to the network. And you will probably store all the information about those accounts in a configuration file, like a .env file or something like that. I mean, so you will be storing the public key, the private key, these sort of things. And everything will work very well until the day that Hedera will reset the testnet network, which is something that they do every 3 to 4 months. And when they reset the network, every single account, smart contract, everything gets removed. So your test will not work anymore at that point. And it will not be obvious to you why they don't work anymore, because they worked the day before. And the solution to that is to use the Hedera Portal API, which is a website. So, I mean, the Hedera Portal is a website where you can log in, and Hedera will automatically create 2 accounts, 2 testnet accounts for you. And it exposes an API that you can invoke using an HTTP GET request to dynamically retrieve all the information about those accounts in a JSON format. So this is what it looks like, the Hedera portal. So first you have to retrieve your personal access token. So you log into the website, you click on personal access token, you create that token, which is unique to you. And then you can just use that token. For instance, here, this is a Postman example where you just copy-pasted the token. You just call this so the HTTP GET endpoint, and you will retrieve a JSON file with all the information about those 2 accounts. that you need. And now, by automating this process of retrieving these testnet account information, you eliminate the need for hard coding the account details in your configuration files. And this not only makes your test resilient to testnet resets, but also improves maintainability and reliability in the long run. So let's move on to the second tip. So this one is about the JSON-RPC node. So first of all, why would you need to use a JSON-RPC node in your application? So there are two main advantages. The first one is that, for instance, you can make it, your application will be compatible with MetaMask, which users are familiar with because they come from the Ethereum ecosystem, most of them. And also you will be able to integrate a library like ethos.js in your application, which many developers are also familiar with. So those are two good reasons to integrate JSON-RPC nodes into your application. And if you do that, you will probably want to test your application locally. And in order to do that, you will also need to download a JSON-RPC into your computer. And if you do that, you need to know that every single JSON-RPC node requires an operator account to run. That operator account is going to pay for the Ethereum transaction fees. So just to be clear, it's going to pay for the submission fees, submitting the transaction to the Hedera network. The execution fees are going to be paid by the end user. Okay? So what could go wrong? Very simple. If that operator account runs out of funds, all the tests will fail. And you will basically get back an error of 500, which is going to be a little bit confusing. The solution is also rather simple. So basically, at the beginning of your test suite, you should programmatically check that the operator account has enough funds to run all the tests. If it does, you continue with your test. If it doesn't, just stop the test and send back an error message that clearly indicates what is going on. OK, so third tip and last one. So before I go into the tip, you need to know a couple of things about Hedera. The first one is about the gas consumption. So whenever you send a transaction to Hedera, you need to set a max gas value, which is the maximum amount of gas that you're willing to pay for that transaction. And you need to know that in Hedera, you will always be charged at least 80% of that amount. Even if the transaction consumes way less than that, you are still going to pay 80% of it. And the second thing you should know is that Hedera has a gas per second throttle, which, if it is reached, it will send back an consensus gas exhausted error. Now, keeping those two things in mind, if you're running tests in parallel, you might hit that consensus gas exhausted error. And it will be very difficult to reproduce because it will not always take place at the same, when you run the same test. It can change, it can look random, okay? So there is no perfect solution, to be honest, to avoid that error if you're running multiple tests in parallel. But there are like 3 advices that I could give you in order to reduce the chances of getting that error. The first one would be to reuse smart contracts between tests. Deploying smart contracts on Hedera is very expensive in terms of gas. So if you're deploying a smart contract for each single test that you run, you will be consuming a lot of gas, and you will probably be reaching that limit. So if you reuse the same smart contract from one test to the other, you will reduce those chances. The second advice is to reduce the maximum amount of gas that you're setting for each transaction. The best way to do that is to try the same transaction multiple times in order to know more or less what it is supposed to consume, then add maybe 20% to that, and that should be the max gas limit that you set for the transaction. Do not set a value that is too high just to be sure that the transaction will go through. Just try to reduce it as much as possible. And the third advice would be to not parallelize gas-intensive transaction. Obviously, that will depend on the use case, on what transactions you have, on what tests you're running, but instead try to parallelize only lightweight transactions when possible. And if you do all of that, you will reduce your chances of getting that gas consensus error back. So, quick recap of the whole presentation. So the first tip was to dynamically retrieve from the Hedera portal API your testnet accounts at the beginning of your test suite to handle all those resets that remove all the accounts that you may have previously created. The second tip was to ensure that your local JSON-RPC nodes operator account has enough funds to run all the tests that you need to run afterwards. If it doesn't, then don't even start running the tests. And the third tip, last one, was to reuse these smart contracts, accurately estimate the gas cost of each transaction, and avoid parallelizing high gas transactions to handle the gas throttling errors that Hedera has. And that's it. Thank you very much.